Today we have the mechanism of a Fischer Esterification, and we're starting off with a carboxylic acid, and it needs to be in the presence of some kind of acid like sulfuric acid. So the first step of this mechanism is the lone pairs on the oxygen comes and picks up this proton. And then you can see that this is a positively charged on the top now. So what's going to happen then is we're going to use a generic alcohol. In this case, we're using methanol. And what methanol is going to do is the oxygen on methanol is going to come in and attack this carbon right here on the carboxylic acid. And this is going to allow for this double bond to push electrons out onto this group right here. So the next step of the mechanism is we come over here and we see that the electrons have been pushed out here, so there's no longer positive. But this oxygen is positive now since it formed a bond with that carbon. So what's going to happen is this hydrogen right here is going to break off and it's going to donate its electrons onto this oxygen. So then we have this molecule here with this, it's making its way to becoming an ester, but we still have two hydroxyl groups on this molecule. So what's going to happen now is another proton from the acid that's been added is going to come in, and one of the oxygens, the lone pair, is going to come in and pick up the proton again. So now we have an H2O group that's positively charged, and that makes for a good leaving group. So what's going to happen is this is going to leave, and the lone pairs from this other hydroxyl group, they're going to be pushed in to form a double bond. So this is what you see in this molecule right here. You have a double bond. You have this OCH3 group that's been attached from here, but this is still positive. So we need to get rid of this positive charge. So water is going to come in, and the lone pairs on water is going to come in and take this hydrogen here, and this bond's going to break and come onto this oxygen here. And now you're going to finish with this final ester group.